Before we proceed on our discussion, let me present to you our objectives. At the end of this video, you should be able to illustrate the center radius form of the equation of a circle, transforming standard equation to general equation of a circle, transforming general equation to standard equation of a circle, determine the equation of a circle given the center and radius, determines the center and radius of a circle given its equation. Let's get started. First, let us illustrate the standard form of the equation of a circle. The standard equation of a circle with the center h, k and radius of r units is quantity x minus h quantity squared plus quantity y minus k quantity squared is equal to r squared. The values of h and k indicates that the center is translated h units horizontally and k units vertically from the origin. If the center of the circle is at the origin, the equation of the circle is x squared plus y squared is equal to r squared. Let us now discover how to identify the standard equation of a circle. Write the standard equation of a circle with the given center and radius. Number 1. Find the equation of a circle whose center is at 2, 7 and the radius of 6 units. Since the center is 2, 7, we can already identify our h, which is 2, and the k, which is 7. Also, the radius is 6 units. Since the center is not on the origin, we will use the first equation. Quantity x minus h quantity squared plus quantity y minus k quantity squared is equal to r squared. Then substitute the given values, 2 for h, 7 for k, and 6 for r. So we have x minus 2 quantity squared plus y minus 7 quantity squared is equal to 6 squared. Simplify 6 squared, we have 36. So the standard equation of a circle is quantity x minus 2 quantity squared plus quantity y minus 7 quantity squared is equal to 36. Number 2. Find the equation of a circle whose center is at negative 5, 0 and the radius of 12 units. Again, the center is negative 5, 0, meaning that the h is negative 5 and the k is 0. Also, the radius is 12 units. Since the center is not on the origin, we will use x minus h quantity squared plus y minus k quantity squared is equal to r squared. Then substitute the given values. So we have x minus negative 5 quantity squared plus y minus 0 quantity squared is equal to 12 squared. X minus negative 5 can also be written in the form of x plus 5. Then y minus 0 is equal to y. Then 12 squared is equal to 144. Therefore, the standard equation of a circle is x plus 5 quantity squared plus y squared is equal to 144. Moving on with item number 3. The center of the circle is at the origin and the radius of 15 units. Since the center is at the origin, so we have 0, 0, wherein the h is 0 and the k is also 0. Also, we have a radius of 15 units. Writing the standard form of the circle and substitute the given values. So we have quantity x minus 0 quantity squared plus quantity y minus 0 quantity squared is equal to 15 squared. X minus 0 is equal to x, then y minus 0 is equal to y. 15 squared is equal to 225. Therefore, the standard equation of the circle is x squared plus y squared is equal to 225. For number 4, find the equation of a circle whose center is at 5, 3 and the radius of 3 is square root of 5 units. Since the center is 5, 3, our h is 5 and our k is 3. Also, the radius is 3 square root of 5 units. Writing the standard form of the circle and substitute the given values. So we have x minus 5 quantity squared plus y minus 3 quantity squared is equal to 3 square root of 5 quantity squared. Then let us simplify, writing the left side of the equation and simplify the right side of the equation. 3 squared is equal to 9, then the square root of 5 squared is equal to 5. Then 9 times 5 is equal to 45. Therefore, the standard equation of a circle is x minus 5 quantity squared plus y minus 3 quantity squared is equal to 45. Join me derive the general equation of a circle from standard equation of a circle. First, we're going to write the standard equation of a circle. Then, the general equation is obtained by expanding the standard equation of a circle. So we have quantity x squared minus 2hx plus h squared from x minus h quantity squared. Then, y squared minus 2ky plus k squared from y minus k quantity squared. Next is to remove the parentheses. After that, let us rearrange the terms. So we have x squared followed by y squared followed by negative 2hx, then negative 2ky, then we have the h squared, then the k squared is equal to r squared. We're going to transpose r squared to the left side of the equation. So the resulting equation is x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared is equal to 0. We will let d is equal to negative 2h, e is equal to negative 2k, and f is equal to h squared plus k squared minus r squared. So the general equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. Again, the general equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. Let us now identify the general equation of a circle. To do that, we can use two different solutions. Write the general equation of a circle with center C, which is 4, negative 1, and the radius of 7 units. Also, determine the values of D, E, and F. For the first solution, we're going to write the center 4, negative 1 and identify our H, which is 4, and our K, which is negative 1. Then the radius is 7 units. Writing the standard equation of a circle by substituting the given values. So we have quantity x minus 4 quantity squared is plus quantity y plus 1 quantity squared is equal to 49. Then we can now transform this into general equation by expanding x minus 4 quantity squared. That is x squared minus 8x plus 16. Since x times x is x squared, x times negative 4 is negative 4x times 2 is negative 8x. Then negative 4 times negative 4 is 16. Also, we expand y plus 1 quantity squared. So y times y is y squared. Y times 1 is y times 2 is 2y. Then 1 times 1 is 1. After that, we can now remove the parentheses. We can now arrange the terms in the given equation. Let's start with the quadratic term, which is x squared followed by y squared. Then the linear term, negative 8x plus 2y. Then the constant term, 16 plus 1 is equal to 17, equal to 49. Transpose 49 to the left side of the equation, then simplify. So we have x squared plus y squared minus 8x plus 2y. 17 minus 49 is equal to negative 32. So the general equation of the circle is x squared plus y squared minus 8x plus 2y minus 32 is equal to 0. After identifying the general equation of a circle, let us now determine the values of d, e, and f. The general equation of a circle is x squared plus y squared minus 8x plus 2y minus 32 is equal to 0. The form of general equation is x squared plus y squared plus dx plus ey plus f is equal to 0. By examining the two equations, we can conclude that our d is equal to negative 8, our e is equal to positive 2, and our f is equal to negative 32. We will now answer the same problem with different solution. For solution number 2, we will first determine the values of d, e, and f, then write the general equation of a circle. We all know that the center is 4, negative 1, so h is equal to 4, k is equal to negative 1, and r is equal to 7. Also, the radius is equal to 7. We all know the general form equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0, wherein d is equal to negative 2h, e is equal to negative 2k, and f is equal to h squared plus k squared minus r squared. We will now substitute the given values to identify our d, e, and f. So for d, we have negative 2 times 4, since h is equal to 4. Negative 2 times 4 is equal to negative 8. For e, we have negative 2 times negative 1, since k is equal to negative 1. Negative 2 times negative 1 is equal to positive 2. For the value of f, we have 4 squared plus negative 1 squared minus 7 squared. Since h is equal to 4, k is equal to negative 1, and r is equal to positive 7. 4 squared is equal to 16, negative 1 squared is 1, 7 squared is 49. 16 plus 1 is 17, minus 49 is equal to negative 32. After we determine the value of d, e, and f, we can now substitute it in the general form equation of a circle. So the general equation of a circle is x squared plus y squared minus 8x plus 2y minus 32 is equal to 0. Our next topic is finding the center and radius given the equation of a circle. Number 1. Find the center and the radius of the circle x squared plus y squared is equal to 81. The center is at the origin, or 0, 0. Hence, it can be transformed to the form x squared plus y squared is equal to r squared. So our x squared plus y squared is equal to 81 can also be written in the form of x squared plus y squared is equal to 9 squared, since the square root of 81 is 9. So the radius is equal to 9. Number 2. Find the center and the radius of the circle. Quantity x minus 3 quantity squared plus quantity y plus 4 quantity squared is equal to 36. The center is not on the origin. Hence, it can be transformed to the form quantity x minus h quantity squared plus quantity y minus k quantity squared is equal to r squared. So our equation can be written in the form of quantity x minus 3 quantity squared plus quantity y plus 4 quantity squared is equal to 6 squared. Since the square root of 36 is 6, we can easily identify our h, which is 3, then our k, which is negative 4. So the center is at the point 3, negative 4. Also, the radius is equal to 6. Number 3. Find the center and the radius of the circle x squared plus quantity y minus 1 quantity squared is equal to 7. Our center is not on the origin. Hence, it can be transformed to the form quantity x minus h quantity squared plus quantity y minus k quantity squared is equal to r squared. So, our equation can be written in the form of x squared plus quantity y minus 1 quantity squared is equal to the square root of 7 squared, since the square root of 7 is not a perfect square. We can easily identify our h, which is 0, then our k, which is positive 1. So the center is at point 0, 1. Also, the radius is equal to the square root of 7. Last number, number 4. Find the center and the radius of the circle x squared plus y squared minus 6x minus 10y plus 18 is equal to 0. This is written in general form. To find the center and the radius, we must transform this to standard form. Let us now transform general equation to standard equation. First step is to transpose the constant number to the right side of the equation. So we have x squared plus y squared minus 6x minus 10y. Then transpose 18, it will become negative 18. Step number 2, group the terms of x and the terms of y, then perform completing the square. So the terms of x are x squared minus 6x, and the terms of y are y squared minus 10y is equal to negative 18. Then we will now perform completing the square. So we have x squared minus 6x blank plus quantity y squared minus 10y blank is equal to negative 18. So to do that, we will add both sides of the equation the square of 1/2 the coefficient of x. The coefficient of x is negative 6, so the 1/2 of negative 6 is negative 3. Negative 3 squared is 9. We will add 9 on the left side and on the right side of the equation. Then, we will add both sides of the equation the square of 1/2 the coefficient of y. So the coefficient of y is negative 10. 1/2 of negative 10 is negative 5. Negative 5 squared is equal to 25. We will add 25 on the left side and on the right side of the equation. Step number 5, factor the left side of the equation and add the right side of the equation. So the factor of x squared minus 6x plus 9 is equal to x minus 3 quantity squared. Since the square root of x squared is x, copy negative, then the square root of 9 is 3. Also, the factored form of y squared minus 10y plus 25 is y minus 5 quantity squared. Since the square root of y squared is y, copy negative, then the square root of 25 is 5, is equal to negative 18 plus 9 plus 25, that is 16. We can also write it in the form of quantity x minus 3 quantity squared plus quantity y minus 5 quantity squared is equal to 4 squared, since the square root of 16 is 4. Now, we can easily identify our center and the radius of the circle. By looking at the standard equation, we can say that our h is 3, our k is positive 5, so the center is 3, 5. Also, the radius is equal to 4.